All right, 9.7b, probability. Ryan's going to start us out.
In Arizona's pick game, a player chooses 6 different numbers from 1 to 44. If these 6 numbers match the 6 numbers drawn in any order by the lottery commission, the player wins or shares the top prize. What is the probability of winning the top prize if the player buys 1 ticket?
All right, player buys 1 ticket. All right, so I always like to start out with my sample space. All right, so does order matter? No, so it's a combination. All right, so how many numbers do I get to choose from? 44. And order does not matter, so it's a combination. And then what goes on the bottom? How many am I choosing? I'm choosing 6. Now, what is my likely outcomes? What goes up top? 1. Why is it a 1? Because I only bought 1 ticket. So now we bust out our handy dandy calculator. Here we go. So we have 1 out of 7,059,052. All right. All right. Mariah's going to read. She might go to college. Here we go.
The numbers of colleges and universities in various regions of the United States in 2007 are shown in figure 9.11. One institution is selected at random. What is the probability that the institution is in one of the 3 southern regions?
All right, so I always like to start out with my sample space. So what do we need to do for our sample space? We add up everything. So go. 4,309 colleges or universities around the United States in 2007. Now, what is my likely outcomes up top? What do I need to do to put that? I need to put out my South region. So I need West South Central, East South Central, and South Atlantic. So we need to add those together. And so we end up with 1,420. All right. Now, we talked about this a little bit yesterday. Probability is between 0 and 1. 0 being not very likely, 1 being super duper likely. All right. So we're going to put this in decimal form. So let's put it in decimal form. We end up with 0.3295. All right. So about 33% chance of choosing a Southern college at random. Yours will be much higher than that. All right. All right, let's keep going on probability of unions. All right, so McKinley's going to read this one. If A and B.
If A and B are events in the same sample space, the probability of A or B occurring is given by...
All right, I'll help you read it. The probability of A unioned with B
is equal to P of A plus P of B minus P A of union B.
That one's an intersection of B. All right. All right.
If A and B are mutually exclusive, then P A union B is equal to P of A plus P of B.
Good. All right. So this is how we use the first one. Whenever we have a union, all right, things that go together, we have a probability of A union with B. We just take the probability of A plus the probability of B, and we have to subtract out what they intersect or what they have in common, because you don't want to double it up. All right. And I think you'll understand after I do this first example how that works. All right. If they are mutually exclusive, which means they don't really go together much at all, we just add them together. All right. So if we have a union and they don't really have any overlaps, what they don't share in common, we just add them together. All right. So let's look at this one. I have one card that's selected from a standard deck of 52 playing cards. What is the probability that the card is either a heart or a face card? All right. So let's talk about the hearts. What is my probability of getting a heart? 13 out of 52. All right. 13 out of 52 cards are hearts. All right. Now let's talk about the faces. So, which cards have faces on them? How many do I have there? I have 12 out of the 52. All right. And now, do any of those things have hearts and faces? Yes. So some of them actually have hearts and faces. All right, so I need to subtract that one out. So how many does that have happen? I have 3 out of the 52. So I need to add these together, and then I need to subtract out the intersections of it. All right, because you'd be adding them twice if you did it. So I do a little bit of math, and I end up with 22 over 52. All right, you see how those aren't mutually exclusive? We need to subtract out those intersections. All right, I want to put it in a decimal form. Let's round to the nearest 4th decimal. Point what? 4? 231. So about a 42% chance of getting a heart or a face card. All right, let's keep. Here we go. I need another reader. Thank you so much, Kendall, for volunteering.
The personnel department of the company has compiled data on the numbers of employees who have been with the company for various periods of time. The results are shown in the table. If an employee is chosen at random, what is the probability that the employee has a 4 or fewer years of service?
All right, let's do A first. So, 4 or fewer years of service. Well, I always like to start out with my sample space first. What do we need to do? We need to do what? Add them all up. Add all of these up. Sample space is 529 employees. And then what goes up top? What are my likely outcomes for a 0 or 4 or fewer years of service? 157. So I put in 157 there. Now, I'd like you to go ahead and put it in decimal form. So we end up with 0.2968. So about a 30% chance of having 0 to 4 years of service. All right, let's look at part B. All right, I'll read it. 9 or fewer years of service. So we have 9 or fewer years of service. So what's still my sample space? 529. All right. And then if I have 9 or fewer years of service, what do I need to do? Add 157 with 89. So I add 157 with 89, and I end up with 246. Do I need to subtract out anything on this one? No, because these are 2 mutually exclusive events. You see the difference from this one and the last one? All right, they don't have any overlap going on. So we type that into our handy dandy calculator, and we end up with 4650. All right. I'm going to read the probability of independence.
A random number generated.
Whoa.
If A and B are independent events, the probability that both A and B will occur is P from quantity A and B equals P of A times P of B.
All right, so this is kind of what I want you to write down. If it says the word and, you multiply. If it says the word and, you multiply. If it says the word or, you add. Okay? And we can kind of look back on some things before a little bit. All right? So if
a random number generator on a computer selects 3 integers from 1 to 20, what is the probability that all 3 numbers are less than or equal to 5?
All right. So I know it says less than or equal to, but that's actually describing the number and not what you're doing with your events. Okay. What's my sample space here? 20. All right. And then my likely outcomes less than or equal to 5. How do I get that? I get 5. Okay, because it's 5 or 4 or 3, 2, 1, and so forth. All right, so there's 5 up there. Now, I'd like to simplify it. What could I simplify that to? I'm going to simplify it to 1/4. All right. Now, I'm going to kind of work with this in the counting principle way, and I'll show you how you can kind of go quicker. All right, so if my computer needs all 3 numbers that are going to be 5 or less, well, what's my first one going to have a chance of? 1/4. And then what's my second one going to have a chance of? 1/4. And then what's my third one going to have a chance of? 1/4. And what do I do with all of those? I multiply them because I need all of them to happen. I need 1, 2, and 3 all to happen. So I'm going to multiply them, and I end up with 1/64. And I want that in decimal form. Point what? 0.0156. All right, so literally less than a 2% chance of that happening. All right, now we could also simplify this 1/4 to a power of what? Of 3. Okay, so that might be a little bit of a quicker way to do it, but it really works with the counting principle. Hello. Here. Thank you so much, Zach.
In 2019, approximately 83% of the adult population of the United States got most of their news from the internet. In a survey, 10 people were chosen at random from the adult population. What is the probability that all 10 got most of their news from the internet?
All right, fantastic. So if I choose one person at random, what's the percentage of that person getting their news from the internet? 0.83, right? All right. And then, how about the second person I go to? What's the percentage of that second person getting it? 0.83. And then the third? 0.83. So it's really 0.83 to the power of 10. So it's really 0.83 to the power of 10. And I end up with point what? 1552. So about 16% of having all 10 people getting their news from the internet. All right, it might even be higher than that. Okay? All right, let's keep moving. All right, now I'm going to talk about a compliment. Okay? So I'm going to talk about Stevie and Mary. All right? So I know you see resemblance. I know. All right, so a compliment is what Rocky Balboa would say is you fill your gaps. All right, so what one has, the other one doesn't. All right, and so we're going to talk about the math of a compliment. All right, so if one's nice, one's not very nice. You know what I'm saying? All right, and so what one has, the other one doesn't, but they add up to be whole. All right. So this is the mathematical way of a complement, and Riley's going to read it for us.
Let A be an event and let A
Prime.
be its complement. If the probability of A is P of A, the probability of a complement is P of A prime is equal to 1 minus P of A.
All right, exactly, because they add up to be 1. The probability of something always happening is 1. But if you do the probability of something and you subtract it from 1, that should be the probability of something not happening. Does that make sense? And sometimes we want to go that method because it will be a lot quicker. All right, so here we go. Kate's going to read for us.
A manufacturer has determined that a machine averages 1 faculty unit for every 1,000 it produces.
You're good. Keep going.
What is the probability that an order of 200 units will have 1 or more faculty faulty units?
Faulty units. All right. I agree. English is crazy. All right. So this is very similar to that one where we had like 25 shipment things and 3 of them were bad. Remember that one? All right. And when we had to figure out when at least 2 were good, and we had to do 2 good, 3 good, and 4 good. And what did we do to all those? We added them up. We added those up. So if this one is asked for 1 or more faulty units, we need the probability of having 1 or more faulty units. So this is really, I could have 1 faulty unit. I could have 2 faulty units. I could have 3, 4, 5, 6, 7, all the way up to what? 200. Does anybody want to add those all up together? No, me either. So I want to go the complement method. I want to figure out what it is on the other side and then subtract from 1. Does that make sense why we're going to go that way? It's going to be a lot less time consuming. So if I need 200 units to have 1 or more faulty units, I want 0 faulty units. I want to do the 0 faulty, which means what? All are good. All right, so I need to figure out the probability of me having all good units. And then I'm going to subtract it from 1, and that will give me my answer. All right, so I'm going to do the complement method. So what's the probability of me getting a good unit? 999 out of 1,000. That's my probability of getting 1 good unit. But how many units do I want? I want 200. So what do I raise it to a power of? I raise it to a power of 200. All right. So if I get all good units, I do 999 over 1,000 raised to the power of 200. And what do I end up getting? 0.8186. All right. But that's all good. Now, the question being asked is having one or more faulty units. So, guess what I want? I want to take the complement of it. So, my complement would end up being 1 minus 0.8186. And so, what is the probability of me getting one or more faulty? 1814. All right. So about 18% of having one or more faulty units. All right. Hello.
You said you raised it.
All right. Write this one down. Page 707. Numbers 31 through 67 odd. However, I want to do another marble problem with you that we're going to make up. 6 blue, 3 orange, and 4 black marbles. All right, go Gators. And then what am I choosing? How many, what am I choosing?
8.
Oh, okay, I'm going to choose 8 altogether. That's fine. All right, but how many blue?
3.
We're going to choose 3 blue. All right. And I'm going to choose 2 orange. And I'm going to choose
1 black.
All right, so we're going to choose 6. All right.
Oh, yeah.
That's fine.
Yeah.
That's fine. It's all good. All right. So I always like to start out with my sample space. So I'm choosing how many? I'm choosing 6 of them. Out of what? How many marbles do I have? 13. So on my sample space, I'm choosing from 13, and I'm choosing 6 of them. Okay? All right. And then now I need to go into specifics going up top. So I'm choosing 3 blue. Well, what do I need to choose from on my blue ones? I got 6 blue, and I'm choosing how many? 3 of them. And I'm going to multiply that. And how many orange ones am I choosing? 2. Out of what? 3. So I'm choosing 2 orange out of the 3. All right. And then I'm going to multiply that with, I'm choosing how many black ones? 1 black out of 4 of them. All right. And so that's what goes up top. All right. And so again, make sure you use parentheses. We'd end up with 240 over 1716. And if we wanted the decimal of it, we would end up with 0.1399. All right, so about 14% chance that you would actually pull that out of the marble bag. Okay? All right.